Okay, so let's look at a few intrusion detection examples using Snort. Okay, so in this part we'll look at a few different types of intrusions and then looking at different methods of scanning that an intruder might take, and then on to some scan detection, especially around how an intruder would sweep over a network. Okay, so normally the basis of any sort of detection is based on some sort of policy. Policies really defines something which fits in with the aims and objectives of the organisation, any legal, moral and social responsibilities, along with the technical feasibility of anything that we try to implement. We then implement a policy in terms of a whole range of things such as operating system rules, domain rights, firewall rules, event logging, application rights, intrusion detection rules, and so on. Once implemented, we then evaluate and make sure that it fits in with the policy that we've actually defined. Once it's running, we need to do an audit at given times to make sure that everything's working. It might be an internal or an external audit, and we audit to make sure these things are working correctly, then verify them again so that they fit in with the policy. So let's have a look at a few different types of intrusions, especially focused on understanding the Snort rule format. Okay, so this shows an example of a rule that we would have for Snort. So we're listening on port 21, the communication between our host and the server. What we're detecting is whenever we see CWD and then ~root. So in this case, the intruder is trying to move to the root folder of the administrator. This is unlikely to be successful, but it might show some form of maliciousness from the user. Okay, so if we analyze the rule itself, so this is taking any TCP port from any external network that we define into our own network on port 21. This is the message that will be displayed, and this defines that the connection has already been established and it's flowing from the client to the server. Then we look for CWD and we ignore the case, so it doesn't matter if it's all lowercase or uppercase. And depth 0 tells us to look at so many bytes into the payload. So in this case we're looking for the very first byte that appears. Then we're looking for ~root. In this case again, it doesn't matter the case of the letters, but we're looking for a distance as in 1 byte away from the other, from the start of the payload, from the other content. Okay, so it's 1 byte distance, typically it's a space in between. Next we define the class type in terms of the type of threat that it actually is. So these are the red flag type classes: attempted admin, attempted user, policy violation, and so on. And then we get the amber ones: attempted DOS, attempted recon, and then we get the low level ones as ICMP activity, network scan, and so on. These ones are definite red flags, these ones are amber, and then these ones are likely to be yellow. Okay, so this shows an example of this type of activity. So in this case, the user connects, does a change the working directory, but has to log in first. These are the commands the user can use. PWD gets the present working directory. Then the user tries to change to the top level, and then tries to change into ~root, then to a list. So with this rule, it's this command here that will be recognized. Again, it probably isn't malicious, but it may show a sign that someone is trying to breach the FTP server. Another example is with peer-to-peer type communications. Unfortunately, most of the communications that happened over peer-to-peer network these days are over encrypted channels, but we can usually find the basic sign of an initial peer-to-peer activity. In this case, we have Napster here sitting on port with 4 8s, and then we look inside the data packet, and this is looking for the content of 000200, and these are in hexadecimal digits, so it's looking for a binary pattern of 4 zeros, 4 zeros, 4 zeros, 0, 0, 1, 0, 4 zeros, 4 zeros. If it finds that and also connected to this port with this offset and this depth, then there is a policy violation that someone may be using Napster. We can also detect content with inside the payloads. So for example, when we download or access a QuickTime movie, then we have a get, and then we post in the HTTP parameters. In this case, we actually define that it's a QuickTime movie. And so in this case, what we'd look for is user agent QuickTime on port 80, and we can detect when someone is running a QuickTime movie. Okay, so this shows an example here. So we can see here, here's the GET request, and there's the user agent here. And this will be able to detect the user agent of QuickTime in the data packets. Okay, user agent QuickTime, and there it is there. Okay, so we can detect things like viruses with inside the payload. So in this case, we're listening on the SMTP port, and this is detecting that there's an exe with inside an email. So an exe might be malicious, and again, there's a file name in there. Okay, so suspicious file name detect is the class type there. As we'll find out, there are certain scans that an intruder might do. One of them is a fin scan, a sin-fin scan. A sin-fin is a very strange mix. It's a start and an end of a connection. So an intruder can send in sin-fin, and in this case we can detect that. Fin scan is purely fins coming in. Null scan, there is no flag set for the TCP parameters. Christmas tree scan is a fin, a push, and an update. And a full Christmas tree scan is all of the flags set together. So this will allow us to be able to detect that type of scan. Okay, another one that we might want to detect is when someone is logging in as root. In this case, we're detecting on port 23, and we're detecting the login. This is a colon root. So let's have a look to see if we can see what that looks like. Okay, so we'll look at our telnet. Okay, so here's the connection, and we can actually have a look and follow the stream. So you can see here is the administrator logging in, and you can see the password is in plain text from there. So the actual The actual snort rule will detect when someone has login and then administrator. Okay, so we can see an example here. Scanning is a tool that an intruder might use to be able to discover things about the network infrastructure. That might include finding out which hosts are on the network, where the network devices are, what the services are that are running on hosts or on servers, or also be able to discover the usernames and passwords. And really what we want to do is to be able to detect with our intrusion detection system the early signs of some sort of maliciousness and to stop it from getting to profit. So the inside reconnaissance might look at discovering hosts inside the network. The discovering of services on a host might be looking for exploits, and also in terms of footholds, the intruder might be looking at usernames and passwords. Each of these three things might not be malicious. It could be that a user has forgot the password, so they're trying lots of different usernames and passwords. It could be that someone is trying to discover if their computer is connected or not. So it's not necessarily that these are always the sign of maliciousness, but we probably need to be running an IDS to be able to detect some of these things. So either to stop the intrusion before it happens, or to make sure that if something does get to profit, we understand the steps that an intruder took to be able to get to that point, and then to be able to stop it from happening in the future. So one of the methods that an intruder might use is to be able to discover the services or the ports that are enabled on a host or a server. For this we can use TCP scans or UDP scans, and a tool that we often use is netstat. And we just have a look at this command. So for this we should be able to look at the ports that are actually open and listening. So in this case 135, 443, 455 and so on. If we go to our VM, then netstat -L will show us the listening ports. And in this case on our VM we have a web port, port 80, FTP, telnet, SMTP, and so on. And these are the ports that someone could connect to. And as we've seen from previous lectures, we can connect to the web service and so on. Okay, so we'll go into more detail about Nmap later. The key thing with Nmap is that you should only really run it within an isolated environment on a private network. So we'll actually just look at what the basic footprint is that we want, and we're on a private network here. So let's start capturing. And with Nmap we get various options. So to do a scan, we can use the -SS option to do a basic scan for the ports that are enabled. And we just check the IP address here. And we're on 47.132. Okay, so here we are. Okay, so you can see these were the ports that we looked at on the server: FTP, telnet, HTTP, and so on. And the basic footprint is this. So this is the Nmap trying all the ports on the server, and you can see it sends in lots of sinks on lots of SYNs on different ports. It will eventually get a reply back for FTP, telnet, and HTTP, and they will actually determine that those ports are actually open. Okay, so that's one types of scan. If we want, we can actually have a look at a UDP scan just to show what it looks like. And this time we should see lots of UDP type traffic. There we go. Okay, so this is UDP, so Nmap is trying on lots of different UDP ports to see which ones are actually open. It's taking a little bit longer, but you can see it continually scans for open ports. The other thing that an intruder can do is actually do a ping sweep. A ping sweep will sweep across a network and ping each of the nodes. You can either do that through an ARP sweep. With ARP, we request an ARP for each of the addresses and see if we get a reply back, or we can do it by pinging each. Obviously, ARP will only work if we're on the local network, where a ping sweep will work even across the internet. So let's have a look to see if we can see a basic footprint. And what we'll do is we'll just stop that capture and then start again. Okay, so we're sweeping across a network, so 24 means 8, 8 and 8 is the first 3 digits here are used for the scan, and the last part is actually ignored. So we can put a 0 in, but it'll ignore it anyway. Okay, so as we're on the local network, we actually find out that we can see this is an ARP scan. So there's the ARP, and the nodes that are alive will actually reply back. So in this case, there is a node that's 135. In fact, it's not at 135, it's at 132. When we look at the ARP reply, it's actually coming back from 132. That's the host. It's replying back to that one there. So in this way, it's discovered there's 3 hosts that are actually alive, and that's been done through the actual scanning process. There's another one that's alive, and in this case it's 47254, which looks like it's a gateway node on our virtual network. So that defines an ARP scan, but normally we would want to go for an ICMP scan. And we can disable that option to take an ARP scan. And then what we see is a whole lot of pings across the network. And obviously the machine which is alive will reply back to the ping. And we can search through. Looking for a reply, and it should get back one back from 132. Just go through. So we can put in a value here. So 0, ICMP type 0 is a reply. Unfortunately, we haven't got a reply back from our host. It may be that ping isn't actually operating on it. ICMP type 13 is a timestamp. We can see that Nmap is actually asked for a timestamp from them, and 8, ICMP type 8 is actually a request. So you can see the standard sign of a request for ICMP. So organizations may block this type of activity on their main firewall, but with inside the network, ARP scanning and also ping scanning may also be possible. The other thing that's possible is the scan of the operating system, and for this the Nmap sends in a request to the host or the hosts, and then we'll do various tests, and at the end of it, it will try and guess what the operating system actually is. So for that, we can use the -OS. Oops. So we want it from there. And it didn't actually find the operating system, but let's do it the other way around. Let's do an Nmap -OS, and then we want to do it for 75.1. Let's check. Sorry, it's -O. Let's try again. And here we go. So we'll do it as a sudo. This should hopefully fingerprint it as Windows 7. Unfortunately, it's not been able to pick it off correctly. So we'll try it on this side again, and -O. Hopefully it should be able to pick off the fingerprint when we scan it the other way. Okay, so you can see this has managed to determine that we're running Linux, even a certain kernel has been fingerprinted, and then the operating system version. The other type of scan that might happen is the scan of user accounts. So packages such as Hydra will read from a file, and then will iterate through all the usernames and all the passwords within inside that list. Typical problems are people with anonymous logins, people who use the same password as their user ID, people with a password of password, root logins, weak passwords, and so on. So this is known as an account scan. So if we have a look at an example here, so let's look at our forensic traces, and this is a Hydra FTP attack. So with Hydra FTP, what we should see is lots of usernames and passwords being tried. Okay, so it opens up new sessions, and we can see here it doesn't manage to get logged in. and it continually tries these until there's a success, after which the administrator can then log in. Okay, so a standard sign of a Hydra type attack is to see lots of usernames and passwords being tried. Okay, so this shows an example. There's the different user names and passwords being tried, and then eventually there is a 230 response, which means that the user has successfully logged in. So in this case, Hydra has managed to find out what the password was. Unfortunately, it was called password for that user. So let's have a look at how we can detect a scan using Snort. Normally what we do is we use a preprocessor, which allows us to intercept the data packets once they've been decoded and before they're passed on to the rules, and to be able to look for certain patterns of intrusion. So there are preprocessors for DNS, FTP, Telnet, and so on. So we're going to use the one that is focused on scanning, which is FS Port Scan. With it, we can define the protocols, TCP, UDP, ICMP, sense level. So low will detect most types of activity, low speed type scanning. And we can define an output log file. In the latest version of Snort, the scan type is not actually included. And all the different range of scan types are done automatically. Also, in the previous version of Snort, we needed to actually define the preprocessor flow option before the preprocessor FS Port Scan. So we run Snort as usual, and we have a rule in there which defines these, the FS Port Scan, and then it should actually show us what it's actually scanning and what the protocols are, and we can also define the things like the memory size, so that we don't overrun our memory, and we obviously define the log name. To test it, we can use a package such as Nmap, and we should always use Nmap on a private network or in a sandboxed environment and not in a public network. So in this case we're scanning a host, and then we should see a log file being set up for it. Okay, so let's go ahead and we'll actually see if we can scan our Linux VM. Okay, so first we'll have a look at our rule, and here we are. This is the rule. We have a memory limit there, low sense, there's the scan, all the protocols, and if we have a look to see what our batch file is, it's going to run verbose, so we should be able to see the data packets, interface 1, and we go into the log folder. Okay, so here's the log folder, so there's nothing in there just now, so we should be able to see that when the log is actually created. So we'll go to our VM. This is in a private address space, and here is the IP address. So what we'll do is that we'll just run the rules file, and then we'll do an nmap on that host 47.132, and the -a will do a whole range of scans on the host. We can see them all coming through now. It just takes a while to complete. Then once this is finished, we'll make sure it's detected everything okay. And then what we'll do is that we'll actually do the same on the other side. Okay, so hopefully when we quit from here, our file will be released, and there we go. So we've got something in our port scan. We can see here this was the host that was so this was the host there was the scanner, and that was scanned. We can see that it's detected this range of ports being scanned from this one address. Okay, so that's worked fine. So what we'll do over here is that we'll actually do vice versa. So you'll obviously have to turn your firewall off because it'll block the pings, and then we'll just run nmaps. So we'll just run it again, and we should be able to detect it coming the other way. 192.168, and this one is at 47.1. Okay, and there it goes. Still running. It just takes a while to do it. It's obviously a little bit slower because we're running within a VM type environment from the server, but you can see the scan is still going on. So the -A option is useful because it gives us a whole lot of information. It does the full scan, so you see it's given us the ports. Okay, it's also given us the operating system type, any trace routes, and so on. So it really does the whole lot. It's obviously not doing a scan, a sweep across the ping sweep across the network, because we're only looking at one host here. Okay, so there we go. So it's found out that we're using Windows 7 Professional Service Pack 1, which is correct. It's found out our work group there. It's found out our system time, and it's found out all the ports that we have open. So when we go to netstat -A here, it should tally up. So we have 135 and 443. 135, 443, and so on. Okay. And we can see our port scan is bigger than it was before. So again, it's picked up the port scan that we did. This time it's come from this host to that host, and it's picked up those ports being scanned. Okay, so that's shown an example of how we can actually scan across our machines.